Hello everyone, in this video we'll be proving an inequality, a topic we haven't done before. So let's get started. We have 1 plus x to the power n is greater than or equal to 1 plus nx. Here x is greater than 0 and n is a positive integer. So I'll be presenting two methods here, first of which is going to be mathematical induction. So to build our induction case, we're going to start with the basic case. All right, so let me go ahead and write it down. The base case is basically, we're going to first of all start with n equals 1, and we're going to show that this is true, this statement is true for n equals 1. Now if you replace n with 1, you get 1 plus x to the power 1 is greater than or equal to 1 plus 1 times x, which is x. And obviously, as you know, any quantity is greater than or equal to itself. So n equals 1, the statement for n equals 1 is true. Okay, let's take a look at the inductive hypothesis. What's our inductive hypothesis? It's going to be, the inductive hypothesis is basically going to be the case for n equals k. So what we're going to do is we're going to suppose that this statement is true for n equals k. And this is what it looks like. 1 plus x to the power k is going to be greater than or equal to 1 plus kx. And our goal is, by using this inductive hypothesis, to prove the case for n equals k plus 1, which looks like the same thing with k replaced with k plus 1. So here's what I'm going to do. I will take this inequality, which is assumed to be true at this point, and multiply both sides by 1 plus x. Since x is a positive quantity, 1 plus x is also positive, so we can multiply without changing the sign. So this is going to give me the following. Of course, I have to multiply both sides by 1 plus x. And the left-hand side, because this is first power, we're going to add the exponents, and we'll get 1 plus x to the power k plus 1 is greater than or equal to the following. Now let's go ahead and distribute that expression. 1 plus x plus kx plus kx squared. All right, so I'm just going to simplify that a little bit. 1 plus x to the power k plus 1 is greater than or equal to. Now here, these two terms, we can factor out x, and that's going to look like k plus 1 times x plus kx squared. Now let's take a look at this expression carefully. If you think about our original expression for n equals k, which is this one, we suppose that this is true and we want this to imply the case for k plus 1. And we actually got the k plus 1 here, the right-hand side at least, but we have an extra term. But that's actually going to be helpful. It's not a problem at all, because kx squared is going to be a positive quantity, right? In this case, k is a positive integer, and x is positive. Obviously, x squared is also positive. So this quantity is going to be positive. What that means is our expression on the right-hand side is going to be greater than 1 plus k plus 1x. Because I have the 1 plus k plus 1x, and I'm just adding a positive quantity to it, which means that it's going to be greater than 1 plus k plus 1. 1 plus the quantity k plus 1 times x. So if you forget about the stuff in the middle, we can safely say that 1 plus x to the power k plus 1 is greater than or equal to 1 plus k plus 1 times x. And this is what we were trying to show. So as a result, we can safely say that this statement here, which is for n equals k, implies this statement here, which is for n equals k plus 1. Exact same statement for n equals k plus 1. And this concludes the first proof method, which is induction. Okay, now let's take a look at this problem from a different perspective. And this is going to be our second method. So we'll start with the original problem. We are trying to prove that 1 plus x to the nth power is greater than or equal to 1 plus nx, where x is positive and n is a positive integer. Now, we're going to be using the binomial theorem. How does it work? Well, if n is a positive integer and x is a positive real number, we can just go ahead and write the following. If you think about the binomial theorem, this expression here on the left-hand side can be written as n choose 0 times 1, which is 1, plus n choose 1 times x, and then n choose 2 times x squared. Since the other term is 1, I don't really need to worry about it, and so on and so forth. Obviously, this is going to continue, but what we see here is if we simplify, n choose 1 is 1, n choose 0 is 1, n choose 1 is n, so we can write it as nx, and n choose 2 can be written as n times n minus 1 divided by 2 times x squared, and so on and so forth. Now, one thing to note here is that we have an expression that is always going to be positive. So this part is basically made up of n choose 2x squared, n choose 3x cubed, and we know that x is positive and n choose r is also a positive quantity. Therefore, we can safely say that since 1 plus x to the nth power is equal to 1 plus nx plus something positive, let's just call that p for positive, this is going to be greater than or equal to 1 plus nx, which means that we are done with the proof. So 1 plus x to the nth power is going to be greater than 1 plus nx if x is positive and n is a positive integer. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Don't forget to comment, like, and subscribe. Tomorrow, I'll see you with another video. Until then, be safe, take care, and bye-bye.